Welcome back, everyone. And the second half of this session is looking for a specific solution to the problems we heard about in the first half. So I'm going to do an initial survey. How many people in this auditorium take daily omega-3 fatty acids? It's a little less than half. So we're going to be talking about fats and lipids and fatty acids. And here's the traditional view. What are fats for? Traditionally, well, they're very calorically dense. But, sorry. In fact, lipids and their components, the fatty acids, are a major biologic regulator. And we're going to see some examples in the next few minutes. And we're going to be focusing on a group of fatty acids that originally start from fish, the fish oil fatty acids, the omega-3. And we're going to look at how they're different and why they're different. So this is a pretty complex slide. If we look here at the top, we see that even fish have to eat essential fatty acids. They eat omega-6 fatty acids and omega-3 fatty acids. And these omega-6 and omega-3 series share the same enzymes to get longer and to make them softer and put in flexibility and double bonds. But they're quite different in their actions. Generally, if we look at the omega-6 series, he's sad. They're pro-inflammatory, pro-apoptotic. They do harmful things in many ways. They do some good things. But if we look at the omega-3 side, we see happy outcomes. And it doesn't come from the essential fatty acids at the beginning. It comes from the elongation of EPA, the bioactive, and the DHA, which is structurally important in the eye and the brain, but is also anti-inflammatory, anti-apoptotic, and generally does many good things. And in fact, when we look, when we think about that question I asked you, omega-3s are everywhere, and they're all oral. And in fact, it's got a huge market, about $40 billion, and they have presumed, of all those controversies, they're good for cardiovascular systems, brain, joints, etc. But oral omega-3 is not good as an acute therapy. And what we're going to be talking about now is acute intravenous omega-3 therapeutics as a new frontier. And that's what this session's about. And we're going to be talking about why acute injectable omega-3 fatty acids are different. And the answer is, we can change by injection omega-3 fatty acid composition of membranes in 30 to 60 minutes compared to oral intakes, which will take 4 to 12 weeks. And we know a number of pathways by which the omega-3s inhibit hypoxic ischemic injury. They all block with their multiple actions, mitochondrial failure, free radical generation, cell death pathways, and this stops problems with cardiac death, epilepsy, cerebral palsy, etc. And this is done not just by the parents, EPA and DHA, but by the multiple derivatives. And we're going to be hearing about some of these derivatives in the next few minutes of the parents, EPA and DHA. Again, they're listed here in different areas of the slide, and I'm not going to go through them. Oops. And we're going to be talking partly, and I'll actually switch most of this to the discussion session of sort of new delivery systems for omega-3 fatty acids in the form of putting 2 fatty acids instead of 3 when we eat chicken fat onto a diglyceride molecule. And we'll be showing you, and I'll be showing you now, that the diglyceride emulsion is much superior to the other forms of omega-3 fatty acids that have been tested. And on the left here, you see a sort of a hypoxic ischemic model in mice, where baby mice get a stroke or lack of oxygen. We look at saline here. We look at the effect of omega-3 triglyceride here, and here's the diglyceride. And that's at 24 hours later after acute injection. On the right, you see an adult stroke model, right middle cerebral artery occlusion, and the red is live tissue, and look at the white tissue. Big, medium, with the diglyceride almost gone. So what we want to hear about now from our 2 speakers is how we make the difference. How are we going to make a difference in terms of pain and injury with the injectable omega-3 fatty acids, on looking at pain, spinal cord injury, and traumatic brain injury.